Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to deal with exercise 6.1 problems of progressions chapter. Even before to this video we have covered the introduction of this particular chapter progression, which you can see in part 1. If you are directly coming to this video, I would strongly recommend you guys to go through that introduction video so that you have a better understanding of this particular thing. And as we are starting on exercise problems, as I told you guys to please go through the examples. I hope you have gone through the examples. So let us get started with the problems today. The very first problem, we have 4 bits. The first bit is already on the board, so let me read it out for you. This problem, it states that in which of the following situations does the list form A, P and Y. Okay. So the first bit says the minimum taxi fare is 20 rupees for first kilometer and thereafter 8 rupees for each additional kilometer. Okay, what is given? The taxi fare for first kilometer is nothing but 20. For the second kilometer, the taxi fare for second kilometer, what he is saying? This, the minimum fare plus additional charge is 8 rupees. For the second kilometer, it is first kilometer plus the 8 kilometer, which is nothing but the additional charge for the second kilometer, which is nothing but 28. Thereafter, the taxi fare for third kilometer, how much it will be? So 20 kilometers for the first kilometer. Now how many kilometers are we traveling extra other than first kilometer? It's nothing but 2 into 8. Okay, 2 8 is 16 plus 20 is 36. And as we move on, and for the fourth kilometer, this is the first kilometer fare plus how many extra kilometers are we traveling other than the first kilometer? 3 kilometer and additional charge. 3 8 is 24. This becomes 44. Alright? Yeah. And for the fifth kilometer, if I am trying to calculate 20 for the first kilometer and for rest of the 4 kilometers, additional charge. Isn't it? So 20 plus 4 into 8 is 32. 32 plus 20 is 52. Alright? So now, if you look at this series, let me consider the first kilometer as, okay, let me write the series as, so therefore, the list becomes 20, 28, 36, 44, 52 and so on as it goes on. So here A is equal to 20, A1. Okay, A2 minus A1 is equal to 28 minus 20 is equal to 8. A3 minus A2 is nothing but 36 minus 28 is nothing but 8. Isn't it? Yes. And likewise A4 minus A3 also, if you calculate 44 minus 36 is also 8. A5 minus A4 is nothing but 52 minus 44. 6 plus 2 is also 8. So the common difference is 8. A is equal to 20. D is equal to 8. Therefore, the series forms an AP. That's the reason I am stressing out to go through the introduction part, because if you have gone through the introduction part, only then you will understand why did I calculate this. Because I have explained this concept in the parameters of the arithmetic progression. How do you understand whether the list is in arithmetic progression or not? By calculating the common difference. How do you calculate the common difference? This is how. Alright. So that is about the first bit of the first problem. Let's look at the second bit of the first problem. What is he saying here is the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. All right, so we do not know solution. We do not know the amount of air present in the cylinder, first thing. So let us assume the amount of air in cylinder be X. Now, vacuum pump removes 1/4 of the air. So, amount of air left when vacuum pump removes 1/4 of the air. That is nothing but X minus 1 by 4. Sorry, X minus X by 4. Which is nothing but 1 minus 1 by 4. 4 minus 1 is 3x by 4. Now, this is what is remaining in the in this cylinder. Okay. Now, within this, from this 3x by 4 also, they are trying to remove 1/4 of the air remaining. Isn't it? So, that's what they are saying, right? When a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. This is for the first time. For the second time, when the vacuum pump removes 1/4 of the air for second time. So we have 3x by 4. That is nothing but 3x by 4 minus 1/4 of this. So what is 1/4 of 3x by 4? 3x by 4 by 4, which in turn becomes 3x by 4 minus 3x by 16. If you take the LCM, this goes on as 16. 4 4s are 12x minus 3x, which is nothing but 9x by 16. So how is this obtained? By the series is x, 3x by 4, comma 9 by 16x, and so on. So if you look at the difference, a2 minus a1, this is nothing but 3 by 4 minus 1 into x, it is minus x by 4. a3 minus a2, 9 by 16 minus 3 by 4 into x. That way it becomes 16. 9 minus 3 4s are 12. That is nothing but minus 3 by 16 into x, which is not the same difference. a2 minus a1 is not equal to a3 minus a2. So, here I am writing it as a2 minus a1 is not equal to a3 minus a2. Isn't it? Therefore, the list is not in AP. Okay. I have solved 2 bits for you. I am remaining the rest of the 2 bits for your practice itself. So let's jump into the next problem, which is nothing but the second problem. So here we are asked to figure out the first 4 terms of the AP given the first term and the common difference. Okay. There are 5 bits in this particular problem. I have chosen the particular ones which I felt you might feel difficult as. So I have chosen the 4th bit and the 5th bit. Okay. So let us solve this problem. What is given for us? Given A is equal to minus 1 and D is equal to 1 by 2. What are we supposed to figure out? First 4 terms. Already 1 term is given for us. We just have to figure out the next 3 terms. Okay. A is equal to minus 1. Second term. First term is equal to A is equal to minus 1. Second term is equal to A plus D is equal to minus 1 plus 1 by 2. That is nothing but minus 2 plus 1 is minus 1 by 2. Alright, third term is equal to a plus 2 into d, a plus 2d, which is nothing but minus 1 plus 2 into 1 by 2 is equal to minus 1 plus 1 is 0. Fourth term is equal to a plus 3d, minus 1 plus 3 into 1 by 2. That becomes minus 2 plus 3 by 2, which is nothing but 1 by 2. Okay, how did I write a plus d, a plus 2d, a plus 3d? Because that is what we have understood from the general form of AP. How is the general form of AP? A plus 2, a plus d, a plus 2d, a plus 3d. That's how it goes on. When they are asking us the first 4 terms, this is how it appears. Okay, therefore the first 4 terms of AP are minus 1, comma minus 1 by 2, comma 0, comma 1 by 2. Okay, that is about the fourth bit. Let's look at the next bit, fifth bit. Okay, here what is given for us? Given first term, which is equal to a is equal to minus 1.25 and common difference equal to d is equal to minus 0.25. Alright, so the second term would be a plus d, which is nothing but minus 1.25 plus minus 0.25. So if you do the addition, that becomes 5 plus 5 is 0, 10, and this is going to be 2 plus 2, 4, 5, minus 1.50, the very second term. And then the third term is a plus 2d is equal to minus 1.25 plus 2 into minus 0.25. 5 plus 5 is 10, 7, 8, 10, and this is going to be minus 2. So the first 4 terms of AP are minus 1.25 minus 1.5 minus, hold on, this is going to be, okay, 1.25 and this is 0.5, right? So this is 1.75 minus 1.75 and the last one is minus 2.0. Okay, that is about the second problem. Let's look at the next problem. So here we have the third problem. Here they are given that for the following APs, meaning they themselves are saying that all the series that are given in this particular problem, the list of numbers is nothing but AP, wherein they are asking us to figure out the first term and common difference. As they have mentioned that the list is in AP, we do not have to calculate the common difference for all the terms. Okay, because already given that the series is in AP, if you just consider the difference of any two numbers, any two consecutive numbers, then that should be fine. Alright, so solution, given, what is the series that is given? Given AP 1 by 3, 5 by 3, 9 by 3, 13 by 3. So the first term is equal to A is equal to 1 by 3 and the second term, this is nothing but A2 is equal to 5 by 3. So the common difference would be always A2 minus A1. So that is nothing but 5 by 3 minus 1 by 3. As you take the LCM, this becomes 4 by 3. Okay. Why am I not calculating for the rest of them? Because it is already given that AP. Even if you calculate, you will get the same result as 4 by 3. Okay, let us look at the fourth bit of third problem. Given AP. That is the reason I am writing, instead of given, I am just writing it as given arithmetic progression because it is already given. Okay, 0.6, 1.7, 2.8, 3.9 and so on. So here the first term is equal to A1 is equal to 0.6, second term is equal to A2 is equal to 1.7, and common difference, which is nothing but D, is equal to A2 minus A1, which is nothing but 1.7 minus 0.6 is 7 minus 6 is 1 and this is 1. So the common difference is 1.1. Alright, that is about third problem in exercise 6.1. Let's look at the next problem. So here we have the fourth problem written. Which of the following are APs? In the earlier problem, they have mentioned that the list is an AP and they asked us to figure out the next terms. Here they are asking us to figure out whether this list is an AP or not. And if they form an AP, find the common difference and write next three terms. Okay, if they are in AP, then we are supposed to figure out the next three terms by writing the common difference. Okay, so let's look at the fifth bit of this particular series. Here given series is, how do you identify whether this is in AP or not? If they have the common difference. Okay, so A2 minus A1 is nothing but 3 plus root 2 minus 3 is root 2. And A3 minus A2, 3 plus 2 root 2 minus 3 plus root 2. 3 gets cancelled, 2 root 2 minus root 2 is again root 2. A4 minus A3 is 3 plus 3 root 2 minus 3 plus 2 root 2. Again 3 gets cancelled and 3 root 2 minus 2 root 2 is root 2. So therefore the list forms an AP and common difference is, what is the common difference? Root 2. So now you have the fourth term. The next three terms would be, so the next term after this will be 3 plus 3 root 2 plus root 2, which is nothing but 3 plus 4 root 2. And again the next one would be 3 plus 4 root 2 plus root 2. That is 3 plus 5 root 2. And again for this we need to add the root 2. Because this is the fixed number which needs to be added to the earlier term in order to get the next term. This is nothing but 3 plus 5 root 2 plus 6 root 2 is, root 2 is 6 root 2. These are the next three terms. Okay, that is about fifth bit. Let's look at the 11th bit. Alright, here a square, a cube, a power 4 are given. Given a square, a cube and a power 4. So how do we understand whether this is in AP or not? By calculating the common difference. A2 minus A1 is a square minus a. If you take a common, this becomes a into a minus 1. And if you do A3 minus A2, this is, A3 is nothing but a cube minus a square. A square becomes common and this is again a minus 1. A4 minus A3, if you do a power 4 minus a cube is common and a minus 1. So a minus 1 is common, but this a term is not common. Therefore, the list does not form AP. And this is not an AP, we do not need to find out the next three terms. Alright, so this is an example of not forming an AP. Let's look at the 12th bit. Okay, given root 2 comma root 8 comma root 18 comma root 32. Okay, for the simplification purpose I'm writing it as root 2 comma root 8 is nothing but root 4 into root 18 as 9 into 2 and root 32 as 16 into 2. That way this becomes root 2 comma 2 root 2 comma 3 root 2 comma 4 root 2, isn't it? Root a b can be written as root a into b. Root 4 is 2, root 9 is 3, root 16 is 4. Okay, this is the simplified series. Now if I am to calculate the common difference, that becomes 2 root 2 minus root 2 is nothing but root 2. Again a3 minus a2. This for this simplification purpose only I have written the series in this form. This is again root 2. And a4 minus a3 is also 4 root 2 minus 3 root 2. If you take root 2 common, this is also root 2. So this is nothing but common difference. What is the common difference? D is equal to root 2. Now how can we obtain the next three terms? By adding root 2 to these things. So that way this becomes the next three terms are, what is the last term? Root 32, right? Root 32, or simply we wrote it as 4 root 2, right? 4 root 2 plus root 2, which is nothing but 5 root 2. If you take this 5 inside the root, that becomes 5 square. 25 into 2 is root 50. Either you can simply write it as 5 root 2 or root 50 is also fine. Again, this becomes 5 root 2 plus root 2 is 6 root 2. 6 root 2 is 36 under root of 36 into 2, which is nothing but 72. So 6 is 12, 2 3 is 6 plus 1. And this is again 6 root 2 plus root 2, which is 7 root 2. 7 sevens are 49 into 2. 2 nines are 18, 2 fours are 8 and 9 under root of 98. So these are the next three terms of AB. Right? So these are the bits I thought I should explain you so that you will have a better understanding. That is about exercise 6.1. And if you like my explanation, please do like, share and subscribe to Anantha Lakshmi Academy. Also do share it with your friends or any of your relatives who are studying in 10th class. In the next session, we will be beginning with the introduction that is needed for us to solve exercise 6.2, like the nth term of an NDP. That concept will be covered in the next video. Alright, so that's about this, and thank you for watching.